region. I said that within
region isn't the same thing as address.
It is, because if you're defining an array,
What?
if you define an array with n elements.
Using optimizations where you separate 2 pointers from pointers to the same memory address, so they don't have to. So the compiler and the processor don't have to reiterate over the cache. That's the whole point. That's literally the whole point of pointer aliasing optimization.
What kind of cache are you talking about?
CPU caches.
What kind?
Well, it depends. If L1 is full, it would be L1.
Okay, we're talking about L1, L2, and L. Do all?
Well, there can be L4. It just depends on the processor.
Do all systems? Okay.
Do all systems what? I mean, now we're getting completely off topic. I'm still waiting for this Godbolt link. I'd love to see how this restricts.
So can you agree that if we said an argument was restricted, right? Can we declare?
Quit saying restricted. That's not right. Proceed though.
If we define the pointer to be restricted, can we declare another pointer within the same context to overlap the same memory region the object pointer is pointing to?
No, that's literally the whole point of what you don't want to happen.
So what happens when you do? Is what I'm just asking you. I'm just trying to get you to understand.
I'm not sure if it'll produce undefined behavior, but it shouldn't happen. You shouldn't be.
It's going to produce more than a single reload.
What's up?
It's going to produce more than a single reload for that specific object.
Yeah, because it's completely
and the code around
denying how it should work.
Code around that.
But listen, having a separate argument is completely fine. It doesn't matter if it's restricted or not. What matters is if you have a pointer accessing.
If it points to the same memory region. I said that within
region isn't the same thing as address.
It is, because if you're defining an array, if you define an array with n elements, if you define an array with n elements, you copy it into the same array, what happens?
Okay, so over time, when you copy an array into the same array,
what happens with
your undefined behavior?
No.
Sure. Okay, then what? What happens?
I'm not going to tell you. You clearly don't understand.
What's the point? Well, no, I want to. What happens?
I'm just proving to everyone
here. If you're not going to tell me,
then
I'll go figure it out myself. I'm sorry for not learning some
odd. You didn't know basic logical operators. Like I clowned you.
Ask me about any logical operators. Go on.
All right, what's the equivalent of?
You done goofed.
Ask me equating, dude. That's not the same. Ask me, what is the AND operator? Logical or bitwise?
What's the equivalent of this operation using an OR operator?
Okay, that's bit manipulation. That's not
A and B. What's the equivalent of using an OR operator? Tell me right now. It's a problem-solving question. Tell me right now.
Yeah, no, that's not. No. Logical operators. Asking me about logical operators and bitwise operators isn't the same thing as asking me bitwise questions.
What's the equivalent of A and B?
I don't know. I don't know anything about bit manipulation. I don't know.
All right, so you're retarded. I got it. Next.
Right. Once again, what does this have to do with C-related logical and bitwise operators?
This is about fluid intelligence. See if you could solve problems on the spot.
Yeah, no, which isn't that's not logical or bitwise operation.
I just proved to everybody you can't solve what A and B is in terms of OR.
Awesome. That's cool.
I know 16-year-olds have.
I have a question. I have a question. When would I use that? When would I need to use that?
To prevent short circuiting. You would use bitwise.
Why not? Okay, so. To prevent short circuiting, that's a bitwise operation. Bitwise operations isn't using short circuiting. It's logical operations for one, and two. Instead of having logical
prevent. No, did I not?
Yeah, no, because no. You asked me a bitwise question. Bitwise has nothing to do with short circuiting.
You're asking me when you're going to use bitwise operators. That's one use case.
No, and you said short circuiting, which is wrong. No, logical operators are used during
to avoid short circuiting. To avoid. I used the word avoid. Is anybody recording this call? Because the compiler.
I'm so confused here.
Operation. The compiler.
I don't know what bitwise operations have to do with short circuiting. It's all about logical operators.
You
asked me a bitwise. You asked me a bit manipulation. Okay, how? How are we going to use bitwise operations over bit?
If you're using an AND logical operator, if you're using an AND logical operator to conduct two expressions, and you need to evaluate the second expression for whatever case, the compiler will optimize it out if the first expression evaluates to whatever. Correct?
Yes, that's the whole point of the AND operator. Oh, actually, no. No. That's not right. No, that's not right. You're thinking of the OR operator.
Bro, if the AND operator...
the compiler will not optimize the second one out. That's the whole point of the AND operation. It's if both evaluate the truth.
Optimized out, you dumb piece of shit.
You just said it was. You just said the second part of the AND expression would be optimized out. Pin, did you hear that? Did you hear that? You said the second half of it would be optimized out.
Bro,
because I want other people to be able to recognize that he said.
I can clown you. You just said.
Go on, explain.
Listen, when you're using the AND operator, if the first expression.
Right. But no. You know why I said the OR operators? Because the OR operator is either or.
Look at the chat. If the first expression evaluates the false, that's going to get short-circuited. That second expression won't be invoked. Am I wrong?
No, you're right. You're right.
So the why?
But that's not what you said.
Let's backtrack.
No, that's not what you said. No. What you said was no.
That's what I said.
No, it's not. No, it is not. No, it is not. What you said is that the first evaluated is true and the second one. Okay, that's fine. I want you to run it back. I want you to run it back. No. Listen here, you little fucking brain-dead ass Mexican. Listen. Shut the fuck up and listen. Shut the fuck up and listen, you brain-dead ass fucking idiot. You said the second operand, not the fucking beginning, not the first one, the second one. Both are required to be true to be able to enter the scope of an if statement.
It's not my problem that you can't understand what I'm saying.
No, it's your problem that you fucked it up. Now, you said it was right, but you corrected yourself.
And evaluates the false. The second expression will be short-circuited. Correct?
Right, that's true. But that's not what you said. That's not what you said.
Why are you saying the OR operator? Why are you talking about the OR operator?
No. Okay, because that's what you said was wrong.
So why listen,
you fucking idiot. If you want to hear my explanation, then shut the fuck up. No, if the first one is evaluated true. Okay, so if the first one is evaluated true, right? Listen, you fucking idiot. So for the logical AND operator, both of the operations have to be thoroughly checked, other than the first one being wrong. So what I said was, you're thinking of the OR operator. So if the second expression evaluated a false, the first one would be taken.
Oh, fuck.
Bro, he doesn't even understand what restrict means.
What?
He's throwing a word
literally
around like
answered.
what Ellie is saying. No, you didn't. He didn't answer at all.
I told you what the restrict keywords were.
You're talking about caches, as if caches were relevant in that context.
Yes, the cache is definitely relevant in this conversation. You fucking
It could be any type of memory. It could be any type of memory, bro. Not all caches.
Okay, so I have a question. If a cache is empty, right? Is the cache going to be used? If it's empty, if the cache line is empty,
what type of memory do registers use, bro? I'm just curious.
None. Registers aren't in memory. Not in memory.
Registers aren't in memory?
No. That's the whole point. That's the whole point of processors. Either you store things in memory.
How does the system know what to use in the registers? What? Oh my god, bro.
Oh, okay, no. You fetch those operands from memory, but the registers themselves aren't in memory. No. That's not right. And he's silent. Yeah, he's right. They're in a register file. Yep.
Bro, you don't even know what type of memory. Like you're just talking about caches as if that's the only thing that's used by a processor for memory. Like, very specific with your language,
right?
Because
but
you want to say, like, you know what you're talking about. No. Let me finish. You want to know?
No, you're not. No, registers aren't in memory. No, registers aren't in memory. I don't know where you got that from. Go ahead. You can Google registers aren't in memory. That's the whole point of what the John von Neumann model is meant to be. Either you can store things in registers or memory.
Bro. It's registers aren't memory, bro. You're right, bro. It just memorizes it out of nowhere, right? It just grabs that value out from nowhere.
No. The value that they use are in memory, but the registers themselves aren't.
Black magic, right? Bro, you sound retarded.
Can you listen, you fucking idiot?
You're literally getting clowned on basic logic.
No. Listen, you little fucking retard.
This is not programming. This is logic.
The operands themselves are in memory, but the registers themselves are not. No, registers are not in memory.
What a bitwise operator is. Firstly, secondly, you fail to understand what short circuit is.
How? I've already explained to you what the
you just got clowned on a restrictive keyword. You just got
how? It's not restrictive. I don't know where you're getting the tip part.
You're trying to use buzzwords like cache or some shit, which is not even involved. It's just abstract, honestly.
It's abstract. No, you fucking idiot. I have a question. If the cache line isn't being used, will the processor store things in the cache line, right?
So
that's the whole point. That's the whole point of cache lines, right? That's the whole point of them. They're meant to speed up your processor. Or your processor's fetching cycle.
So what's one benefit of converting logical to bitwise operators, right?
There is no point. They're completely different.
Really? It's
one is for bitwise operations, the other one is for logical operations.
Converting logical to bitwise operators is a compiler optimization because it removes branches.
Show me.
Which is more efficient when expression evaluation is faster than branch misdirection.
Okay, right. I get that, and I agree with that. Yes. Branchless programming is faster. I agree with that part. That's the only part.
Tell me what I just said.
You said the whole point of converting logical operations to bitwise operations to reduce branching. Branching is quicker than non-branching. That's exactly what you said. Okay, then what'd you say? What'd you say?
Optimized because it removes branches, which is more efficient when expression evaluation is faster than branch mispredictions.
Oh, I didn't hear that part.
You got? I said it. Everybody heard that, right?
Sorry, I must have been talking over you, but no. All I heard was the point is that we convert logical operations to bitwise operations to reduce branching.
I'll be right back.
All right.
Oh, he just left? Just like that?
I guess so.
Damn. Yeah, that's kind of sad.
He's just gonna get some lemonade or something.
No, he's gonna get some fucking water. He's getting packed right now.
Yeah, lemonade's pretty good.
Lemonade is pretty good.
Meow. Fuck, I'm horny, man.
So apparently their shit keyword isn't meant to hit the compiler that you wanted to have pointer aliasing optimization. I guess this guy This guy must be on the fucking C committee team or something, man. He must be the one making all these fucking standards then, because
Exactly.
I don't know, man.
You're right.
Oh, go.
Yeah, man, you're a bro.
Hey, Rocky, what's up?
Yo.
What up, Heather? How are you?
Rocky.
Oh, just here listening to whatever this
dramatic.
is.
I
Yeah.
don't even know who was fighting with NT. Honestly, I don't know who that is.
Some scrub.
I clowned
There's
this
a guy
guy
named Layta.
on basic memory management. He couldn't figure out.
Layta
how
the
So
to-
Resilience.
I'd like to see where are these registers stored in memory?
Oh, okay. NT's back.
Let me ask. So with
secret
NT,
message.
hold on.
Charlie, shut up.
Donkey, shut the fuck up for a second. NT, show me where these registers are stored in memory. NT, I'd like to know where are these registers stored in memory again?
Make a donkey noise.
No.
Yeah, come on.
No.
He's a fucking donkey.
Yo, NT, I have a question,
You looking
man.
like a donkey?
NT, can you
That's
show me
not
where
funny. That's
registers
too
are stored
far,
in memory?
too far.
Oh.
The fuck? That's some weird shit, nigga. The
Fuck this flashcard. Let's see who can make the best donkey noise. Come on.